Okay, so I'd like to take a minute to walk through number 45, the challenge problem. There were 2 students who got this right and earned the extra credit, and several more of you that were pretty darn close but didn't quite do all the work that was required for it. So what I've done is I've laid out our 2 solutions using our quadratic formula, right? And I don't know if they're both positive or if they're both negative, but I do know that if we looked at this on the x-axis and this represented the negative b minus, would be less than the negative b plus, correct? And that the mean or the average of these two would be right in the middle. And we know that right in the middle, if we had a root here and a root here, we've got a parabola. It could also look like this, but it doesn't matter because right in the middle is the vertex. And we know that the x-coordinate of the vertex is equal to negative b over 2a. So this just kind of helps me out a little bit. I know that when I average these two together, I should get negative b over 2a. So now we're just going to do the math. So to average two things together, we're going to add them together and then divide by 2. So we've got negative b minus the square root of b squared minus 4ac all over 2a. And then I'm going to add it to negative b plus the square root of b squared minus 4ac all over 2a. And then I'm going to take that and I'm going to divide it by 2, or since I already have fractions, I'm just going to say times 1/2. And now let's simplify. So this is pretty intimidating. I get that. But notice that the negative b squared minus 4ac and the positive b squared minus 4ac, those are going to cancel each other out. So we have negative b minus another b. This is going to be negative 2b. Remember, when you add fractions, you don't add the denominators, times 1/2. And then from here, we just have a simple simplification here. Those twos can cancel, and we end up with negative b all over 2a. And what is the significance of that? The significance is that is the x-coordinate of the vertex. So a little challenging problem. Congrats to the 2 students who got it right, and congrats to all of you really who tried it.